Okay, let's try some examples that are a little bit more challenging than the ones that we've been doing. These ones will require some thought. In how many ways can all of the letters of the word oranges be arranged if the vowels must be together? Okay, I'm going to underline vowels together, and the vowels must be in alphabetical order. So let's take a look at the vowels first. I've got O, A, and E. O, A, E. O. And then I have 1, 2, 3, 4 other letters, consonants. 1, 2, 3, 4. So if the vowels must be together and in alphabetical order, let's arrange these alphabetically. A, oopsies. A, E, O. These have to be together and in alphabetical order, then what I can do is I can consider this chunk right here to be one big object that travels together. So I can pretty much now say I have 1, 2, 3, 4, 5 objects to arrange, since A, E, O have to be together and in this specific order the whole time. So now if I'm arranging, I have 5 different objects to arrange, so I have 5 factorial ways in which this can be done. Let's try another one that's a variation of that. In how many arrangements of the letters of the word brains are the vowels together? So notice that in this question it just says the vowels must be together. It does not say in alphabetical order. So again, I'm just going to write out A and I here to represent vowels, and then I have 1, 2, 3, 4 other consonants. 1, 2, 3, 4. So in this case, my vowels must be together, so they will still travel together the whole time, but they don't need to be in alphabetical order. So let's just see how many ways I can order them if they were in this order, A, I. So in this case, I have 1, 2, 3, 4, 5 objects again. So I have 5 factorial ways in which I can order the letters with A and I together. However, since they don't necessarily have to be in this order, it could be AI or IA, I need to multiply this 5 factorial by the number of ways that my vowels themselves can be arranged. So A and I can be arranged 2 factorial ways. Here, let's zoom in here. So let's pretend this is just my vowels, right? So I have 2 vowels. 2 could go here, leaving me with 1 to go in the second spot. So there are 2 factorial ways to arrange only the vowels. So altogether, I have 5 factorial ways of arranging the objects where A and I are together, multiplied by 2 factorial, because all of these words could be with either AI or IA. So a good strategy for doing these questions is to first group the vowels or whatever is staying together and consider them to be like one giant blob that travel together, like best friends. Then we can zoom in and figure out how many arrangements within the blob we have. So in this case, 2 factorial. Let's try another one like this. Find the number of permutations or arrangements of the letters in the word kitchen if the vowels must not be together. So in this case, I want the vowels apart. A good strategy for solving a question like this is to think about how, of all the arrangements of the letters in the word kitchen, so all the arrangements is equal to vowels together. Okay, so there are some words in which the vowels are together. Oh, journal is spazzing. And the words in which the vowels are not together. So if I'm interested in, oh, I just spelled vowels wrong. Oh my goodness. If I want, vowels. There we go. So if I want vowels not together, then my strategy can be to find all the arrangements and then subtract the number of words in which the vowels are together. Because I know how to answer this question, because this question of figuring out how many words in which the vowels are together is the same as the one we just did. So first let's consider the number of arrangements in which I have no restrictions at all. So I have 1, 2, 3, 4, 5, 6, 7 letters to arrange. So 7 factorial is the number of words that can be made with no restrictions at all. Now let's subtract the number of words in which the vowels are together. So the vowels in kitchen are I and E. I, E, leaving me with 5 other consonants. 2, 3, 4, 5. So if these vowels are traveling together, then I can use the same strategy I used in the previous question. I'm going to consider them as one blob. So I have 1, 2, 3, 4, 5, 6 objects to arrange. But then I must zoom in and say, okay, how many arrangements do I have of just my vowels? So I could have 2 factorial ways of arranging the vowels. So 7 factorial minus 6 factorial times 2 factorial will give me the number of words in which the vowels are not together. So you could just evaluate that. One more. In how many ways can 4 couples sit together at a movie if the couples must sit together? So I have 1 couple here, 2, 3, 4. So couple must be together, must be together, must be together, and must be together. So the first thing I can figure out is, well, how many different ways are there of ordering the couples? For example, if we call this couple number 4 right here, couple 4 could sit first or between here or here, etc. So there are 4 factorial ways of arranging the couples in general. But now, like in the previous 2 questions, I must zoom in and say, well, how many different ways are there of arranging this couple? So let's pretend that this is a boy-girl couple. There are 2 factorial ways of arranging this couple. It could be boy-girl or girl-boy. So multiply by 2 factorial. The same is true, though, for every couple. The couple number 2 could sit boy-girl or girl-boy. So there are 2 factorial ways of arranging this couple, and 2 factorial ways of arranging couple 3, and 2 factorial ways of arranging couple 4. So in total there are 4 factorial times 2 times 2 times 2 times 2 ways of 4 couples sitting together at a movie if the couples must sit together.